Do you feel the vibes?
This section 8.3 is graphing functions. We're going to start with what we call graphing reciprocal functions. So reciprocal functions are, functions like, f of x is equal to 1 over x. Okay? Okay, so let's take a look at this for a minute. You have a function here, 1 over x, right? Let's talk about domain. Remember, domain is all the values of x that provide defined values for the function, right? So take a look at 1 over x. Can x be a positive number? Sure. Can x be a negative number? Sure. Can x be 0? No. So that's why we say domain is all real numbers except for x equals 0. Now, let's talk about range for a minute, okay? Let's just talk about range. Range is all of the y values that a function can have, correct? So, if x were positive, what would y be? 1 over that, positive. So all of the positive numbers will work. If x was negative, what would y be? Negative. So what value of x gives you y equals 0? None. There are no values of x that you can plug in that would give you a value of 0. So for that reason, for the domain, x can't be 0, and for the range, y can't be 0. So when you go over on the x-axis, on the graph, this is what it looks like. So x can never be 0. That means there is a vertical asymptote there. Okay? So this is a vertical asymptote, and the vertical asymptote is x equals 0. Now y also can never be 0, so there is a horizontal asymptote at y equals 0. Okay, so those are very, very important. And in this case, there are no intercepts because that's when x is 0 or y is 0, right? So there physically can't be any intercepts. All right, let's do a couple of points then. So when x is negative 2, f of x is negative 1 over 2. When x is negative 1, y is minus 1. When x is 1, y is 1, 2, a half. All right? Okay. So here, let's go ahead and graph the functions here. So I have f of x is equal to 2 over x. Right off the bat, I know there is a horizontal asymptote at y equals 0, and there is a vertical asymptote at x equals 0. Because it's the same exact thing here, right? So it's the same exact thing here because x can never be 0. Okay, and so for any of these reciprocal functions, remember how we said for exponential functions there was always a horizontal asymptote, y equals 0. For reciprocal functions, there are two asymptotes, one horizontal, one vertical. Y equals 0, x equals 0. Okay? Okay, so now here is the horizontal asymptote, and here is the vertical asymptote. Okay, let's plug some points in. So I want to do negative 2, negative 1. It can't be 0, right? So 1 and 2. So when x is negative 2, y is negative 1. When x is negative 1, it's negative 2, 2, 1. So negative 2, negative 1. Nope, here. Negative 1, negative 2. And then here, x is 1, y is 2. Here. Okay. So just like we knew what exponential functions looked like, right? Decay and growth. You should know that here it's going to follow the, it's going to follow the vertical asymptote. It's going to follow the vertical, It's just not letting me graph. There's something. Have we done any illegal math? The math gods are speaking to me. Okay, that's where. There we go. Okay? Whew! Oh my gosh, that was harder than I thought. It was physically hard to draw that one, not even conceptually. Oh my goodness. You see that? And, and they say, there are no ghosts. Ha! Okay. All right? That was a math ghost for sure. They were just like, nope, you're not going to graph. Okay. All right. So here we go. I mean, how else could you explain it? Huh? No, not at all. We have to persevere. Okay. So, right? So that's how that looks. They're all going to look like that. Remember, they're all going to follow the horizontal asymptote and the vertical asymptote. Okay. And do you see how there is symmetry here? So if you look at the symmetry, wait, we didn't talk about even and odd functions in this class, did we? No, never mind. Okay, let's move on. So let's look at this one. Negative 3 over x. Now, what do you think that negative does in the front? It's okay, give me the reflection around the x-axis. Good, it's a reflection around the x-axis. So we already know what's going to happen, right? This is going to flip over, so everything up here is going to go down there and vice versa. So let's take a look here. What is the horizontal asymptote here? Y equals 0. And the vertical asymptote? X equals 0. Remember, if you just say 0, it will never be full credit. You have to say x or y equals. You have to write x equals 0, y equals 0. So most likely on the test, I'll ask you, write the vertical asymptote and the horizontal asymptote. Okay, so let's plug in some numbers. Okay, so for this one, I plugged in negative 2, but it doesn't make sense to plug in negative 2 here, right? I might as well plug in negative 3, negative 1, 1, and 3, right? Like, you can control that. So here it's going to be 1, 3, negative 3, negative 1. Okay, so I put down the asymptotes first, horizontal and vertical. Remember, if you're using a pencil, which you all should, you can do it like a hairline above or to the left or to the right of the axis so it's visible. All right, so let's see. When x is negative 3, y is 1. Negative 1, y is 3. And then 1, negative 3, 3, negative 1. And again, it should look like this. Okay? So do you see how this is a reflection? Because on the first one, the right-hand side was above the x-axis, and now it's below. But notice, when we went from 2 over x to 3 over x, there is also a little bit of a vertical stretch, right? And you can physically see that it's less curvy, right? That's the vertical stretch. All right. So now let's talk about transformations. So transformations of these functions work in the same way. All right, so what was the parent function? The parent function was f of x equals 1 over x. So now, if I introduce a minus h here, right, next to the x, what does that do to the graph? It's a what? It moves it where? It's a horizontal shift. Good. Okay, what about the plus k? Vertical shift. And so A, what does A do to the graph? If the absolute value of A is greater than 1, it's a stretch, vertical stretch. If the absolute value of A is between 0 and 1, it's a vertical compression. And then if A is less than 0, it's a reflection around the x-axis. Okay, so now, if I take this graph and if I apply a horizontal shift to it, if I move it left and right, the vertical asymptote also moves left and right. And if I move it up and down, the horizontal asymptote also moves up and down, just like it did for our exponential functions. So how do we find the horizontal asymptote? It's going to be x equals h. The vertical asymptote is going to be y equals k. Okay? The domain and range will stay all real numbers except x can never be h, y can never be k. So it's just going to move. Okay? All right, so take a look here for a minute. All right, so first of all, let's talk about the horizontal asymptote. The horizontal asymptote, now look, x plus 3, right? There has been a shift to the x plus 3. So when I say x plus 3 equal to 0, x equals negative 3, the horizontal asymptote is x equals negative 3. So what happens when x equals negative 3? What does the denominator equal? 0. When the denominator equals 0, the function is undefined. That's where the vertical asymptote. Sorry. This is vertical asymptote. I'm so sorry. Okay. Whenever the denominator is 0, that's where the function is undefined. That's where a vertical asymptote happens. This is very, very important. Denominator 0, function undefined, vertical asymptote. Okay, these three things are the same. So if the function is undefined at x equals negative 3, that means the domain includes all numbers except x equals negative 3. So we say the domain is all real numbers, but x cannot equal negative 3. And take a look here for a minute how the vertical asymptote and the part about the domain that we leave out are the same value. Okay, range. So vertical asymptote is x equals negative 3. Now horizontal asymptote is y equals 0, because has this moved up or down? No. It has not. So the range then is all real numbers, but y cannot be 0. And again, whatever the horizontal asymptote is, that's the value that you exclude from the domain. Okay? Yeah.
Wait, so then for this, then domain could be 0?
Correct. Okay. 0 is included in the domain. So the domain excludes all the numbers that make the denominator 0. Okay, so now, horizontal asymptote and vertical asymptote. Okay, now, how do we know what numbers to plug in? Basically, go to your vertical asymptote, right there. Negative 3, right? X equals negative 3. Now, remember how for the parabolas, we would go to the axis of symmetry and we would pick points from, either side of the axis of symmetry? Same situation. Go here and pick points to the left and to the right. So I'm going to pick negative 4 and I'm going to pick negative 2. So negative 4, negative 2. So when x is negative 4, this is going to be 2 over negative 1, negative 2. 2 over 1, positive 2. So let's go over here. When x is negative 4, we're at negative 2. When x is negative 2, we're at positive 2. And then what else can I pick? I can go one more to negative 5 and negative 1. So when x is negative 5, what do I get? 2 over negative 2, negative 1. Oh, no, negative 1. And then when x is negative 1, I get 2 over 2, positive 1. Okay, and now I can go ahead and graph like this. Okay? Yeah. Okay, so take a look now. Watch. This was 2 over x. Now look at this. Now let's shift the whole thing left 3 spaces. That's what we get. You see that? Okay. Isn't that cool? All right. So now, what kind of a transformation is there on this graph? Down 4. Okay. So the vertical asymptote is x equals 0. That hasn't moved anywhere. But what about the horizontal asymptote? Y equals -4. Okay? Now, what's the domain? All real numbers. X can't be 0. The range is all real numbers. Y can't be -4. Okay, so what numbers am I going to plug in? Well, my asymptote is x equals 0. So I'm going to do -1 and 1. Oh, shoot.
Oh. So you look at the vertical?
So you can, yeah, look at the vertical because you want to plug in x values, right? So we're going to go -1 and 1. 1 on the left side, 1 on the right side. Now look at what I'm going to do. So when x is -1, this is -1 minus 4, -5. 1 minus 4, -3. Okay, now I want to pick another point on the left side and another point on the right side. I can always pick 2, but then I'm going to have half minus 4. Or, what else can we pick? Oh, why don't we do, huh?
0.5.
Oh, 0.5. Now you're getting all sorts of creative on me.
No, you could just give you half.
That's right.
No. But you need 2 for f of x.
Oh wait, that would.
Oh, that would work if it's with the half thing.
See how creative that was? How awesome is that? Okay, but listen. Would you hate me if I branched out and chose like -4?
Oh.
Just for fun? I know we're not going to get a whole number.
Oh.
Okay, if I do -4, then it's -1 over 4 minus 4. So how much is that? Don't worry about fractions. It's -4.25, right? Because -1/4. Oh, okay. Yeah. Okay, so -1/4 and 1/4, so it's 4 1/4.
Could we just leave it as that?
You can leave it as a fraction. Do what you want.
Why would we do a -4 if you do like -2?
Because it's a free country and I wanted to do -4 because I overcame the math ghost earlier and now I'm powerful and can do whatever I want. But really the reason why I chose -4 is to show you guys you can plug in any number that you like. Okay? Any number that you like. You could even do a half. Besides 0. Good. Okay. So now let's do a 4. So that'll be 1 over 4 minus a 4. That's 3.75. Here. All right.
Yeah, isn't it?
Sure. I graphed it in the right place. So that's how that looks. Okay? I'm going to require that you take at least 2 points from each side of the asymptote. Okay. So, let's go to the next one. And here is what I want you to know. Whenever you have rational functions like this, you immediately have to go to the denominator. You take the denominator and you set it equal to 0. And you get x equals 1. That gives you 2 pieces of information. The first piece of information is that the vertical asymptote is x equals 1. The second piece of information is that that's the point we exclude from the domain. So it's all real numbers, x can't be 1. Do you see what I did there? I went straight to the denominator, set it equal to 0. I use the point I get from that to get my vertical asymptote and the point in my domain. Okay? Now, then you go to this number, k. K can be 0 or it could be another non-zero number. That value k tells you the horizontal asymptote is y equals that number. And it also tells you that the range is all real numbers, but x can't equal that number. Okay? Okay. So, oh, y. Oh my gosh. Y, thank you. So, y can't be 2. Told you, I haven't taught all day. My brain's getting rusty. 1. So now I need to plug in a number from either side of that vertical asymptote. So let's plug in a 0 and a 2, right? First. Yes, because this time it's not like the domain doesn't include 0, right? It's shifted. So whereas the bad point was 0 in the other problem, now the bad point shifted to 1. Okay? Okay, so let's do 0 and 2. So when I plug in 0, I get 1 plus 2 is 3. When I plug in 2, what do I get? No. 0, I get 1. 2, I get 3. So 0, 1, 2 is 3. Okay, and then why don't we plug in a minus 1 and a 3? So if it's a minus 1, it's what? Negative a half plus 2, so that's 1.5. And then if it's 3, 2.5. Uh, 2.5 here. Okay, so now it's going to look like this. All right? All good? Okay, so when you're doing these, the first place you go to is the denominator. So now with that knowledge, let's go back to the very first one. The first place you go to is the denominator. Set that denominator equal to 0. That's the vertical asymptote. This number here, right? This number here, that's your k. Okay? So that's the what? Horizontal asymptote. Yeah. Yeah. Yes, x equals h, that's the horizontal. Oh no, that should be vertical. You're right. You're right. Way to go. Oh my gosh. I really need to. Oh boy. That's what it is. Okay, I need to immediately revise that in the notes. Okay. All right. Good. All right, so let's do some homework.